Hello, my name is Shaika Ganj. I'm a principal applied scientist with Amazon. Today I'm going to talk a little bit about how we use Kubeflow reinforcement learning pipelines for robotics using Ray and Amazon SageMaker. I first would like to thank my contributors across multiple companies, including Max Carlson. Nick's team was very instrumental in getting the code ready for Kubeflow pipelines for us. And I'm going to be talking a little bit about our use cases with Woodside Energy and General Electric Aviation. I also would like to thank the contributors on the Amazon Web Services site and really appreciate all the teams that has contributed to today's presentation. Here is the outline of my talk. I'm going to give you a little bit of the story behind how robotics will be using reinforcement learning workflows in order to learn complex behavior. Then I'm going to talk about how you can use Amazon SageMaker with Kubernetes operators and Kubeflow pipelines. And finally, we're going to look at how AnyScale's Ray can be integrated into these components, such as the Kubeflow and Amazon SageMaker. And then we're going to complete with our customer use cases. I'll be presenting two customer use cases. The first one is with General Electric Aviation, where we're going to be looking at an application where we're in a manufacturing plant and we have robotic manipulators. And my last example is going to be with Woodside Energy, where they're looking into using navigators with manipulators that will enable them to perform plant operations. Let's take a look at robotics reinforcement learning workflow. Reinforcement learning has been around since 1980s. However, over the last decade or so, its application to robotics had become ubiquitous. And this has applications from motion planning to manipulators and to warehouse navigation. What academic and industrial partners had shown is that you can use reinforcement learning for the robots to learn complex behavior and adapt very quickly without having to need to reprogram the robots. And this has been a very valuable trait moving forward for industrial robotics operations. However, one of the enablers for this had been the role of simulation in robotics. Simulation in robotics has made it possible for robots to learn in a relatively safe environment. That means that when reinforcement learning agent is exploring different behaviors that may otherwise have constraints in the real world, robots can perform these behaviors in a simulation environment. Hence, it makes it easier for the reinforcement learning agent to explore various scenarios. And another advantage of using simulation in robotics to train reinforcement learning agents had been that we can introduce different scenarios and different environments, hence enable your robots to be more robust to changing lighting, changing environments with various conditions. However, one challenge once we start using simulation for reinforcement learning has been to successfully transfer your reinforcement learning agents from simulation to the real-world environment. And I would like to highlight here at Amazon and AWS, we've been able to design a robocar which uses custom reinforcement learning models that are designed by our customers who are participating in various summits and events, that they can train, they've been able to train thousands of unique RL agents with different reward functions and successfully transfer these to our robocar. Let's take a look at a few videos from our events. On the left, you see the simulation environment that has been used to train these robots. And on the right, what you are seeing is that literally copy-pasting of the neural network from simulation to real world. And our events are going to be also available at NeurIPS competition this year in collaboration with AI Driving Olympics and Ducky Town. Now let's take a look at how SageMaker and Kubeflow work together in order to enable Kubeflow pipelines to orchestrate various machine learning operations. Let's first take a look at how machine learning workflow works without using any platform. When you're developing a machine learning algorithm, first step is you prepare training data, and then you use this data with an algorithm, whether you developed or whether you use one of the available algorithms that we provide on our platform. And then finally, after you train your machine learning model using the algorithms that you chose, you go through another process of debugging and tuning if the algorithms did not perform and or the model did not perform to your liking and it doesn't align with your outcome metrics. And the final stage that you see is once you're confident that your machine learning model performs within the outcome metrics, now you can deploy your model in production in the environment that you chose. Now let's take a look at how Amazon SageMaker enables you to build, train, and deploy machine learning models. We provide a very easy to use a platform based on Jupyter notebooks where you can collaborate with your teammates very quickly and collect data, train your models using your algorithm and or the ones that we provide. And then at the end, you can put this in production either using SageMaker Inference or you can use our IoT platforms to deploy on the devices of your choosing. So now let's take a look at how you can take a step back and orchestrate all the components of the SageMaker from collecting data to building the models, training them, tuning, and then finally deploying them using Kubeflow. So in 2019, we provided to our customers and to you Kubeflow components and Kubeflow pipelines in order for you to use these components and pipelines for SageMaker and automate the machine learning workflow for build, train, tune, and deploy. Now, the next question we asked in 2020 was, how can we expand this into reinforcement learning environment, where we have reinforcement learning workflows, which has additional components than compared to the things that we had just shown for machine learning. And then we're going to talk a little bit about how we can do this using AnyScale's Ray and RL Lib. Let's first take a look at the new things that we have to add into our SageMaker and or machine learning workflow. First of all, our machine learning workflows were using relatively static data. So you actually collect your data, you prepare it, and then you provide it to your training algorithm. Reinforcement learning is a continuous process of the agent taking feedback from a simulation environment, and then this simulation environment is being used by the agent to create new policy, to create new behavior, and through this iterative feedback loop, the reinforcement learning agent is trained. So the first thing that we had to add to our machine learning workflows and our platform is to be able to continuously collect data from by the agent using a simulation environment. Hence, our second important component that we have to add is a simulation environment. We can have a simulation environment natively built into a service by Amazon and AWS, which is AWS RoboMaker. I'm going to talk about it a little bit, and or you can bring your own simulation environment to train your reinforcement learning agents. Hence, our second component was to provide a means to run your simulation environment while you're training your reinforcement learning agent. Then we go through the process of similar to machine learning process, tuning and making sure that the robot operations within the simulation is actually in the constraints that you provided that you would like to take to the real world. So the final stage in this case is to deploying to a robot. And your robot may have different compute platforms. We provide a seamless deployment if you have a robotic operating systems integrated into your robots. Otherwise, you can use our IoT platforms to enable the robots to utilize the inference node from SageMaker. Now that we have our three new components added into the SageMaker, we do have a SageMaker reinforcement learning platform and a workflow that we can utilize to start our process with Kubeflow Pipelines. Let's take a look at how Kubeflow Pipelines orchestrates our services. Similar to the machine learning workflows, we have our SageMaker estimator here, and we use the Kubeflow Pipelines interface and a scheduler not only to instantiate and start running our SageMaker reinforcement learning agent, but we also use AWS RoboMaker, which is a cloud robot simulation service that you can utilize. And this is probably the most complex use case that you can have. You can still use the Kubeflow pipelines to orchestrate your SageMaker with other simulation engines, and we provide extensive documentation on how you can do that. In this most complex case, Kubeflow Pipelines is orchestrating both the trainer and the simulation environment. And by doing that, we're also able to decouple the training and the simulation, which means that we can scale the simulation by generating multiple simulators, and also we can scale using scaling the number of trainers. And this is where Ray RL platform is quite useful. So let's take it one step deeper and look under the hood of AWS SageMaker and see how it uses Ray's and RLlib in order to train the reinforcement learning agent. On one side, we set up a Ray cluster in Amazon SageMaker, and we create a policy which is going to be our trainer, and it's going to create rollout data and push that into the policy server input. And then this policy server input is communicated to the AWS RoboMaker, which is our simulation environment. In our simulation environment, we also have a policy, and the policy on the trainer and on the simulation are going to be the same as long as until a new policy is made available by the trainer. So on the simulation side, the simulation agent is taking the policy and using the policy client in order to use this policy and generate new experiences using the simulation environment that is provided as a cloud service. And through this loop, what we are doing is that we're using Ray, and we're using its component, two of its components, policy server input and policy client, in order to orchestrate between SageMaker and AWS RoboMaker, and we're able to train our agents using behaviors. And on top of that, we had the Kubeflow pipelines that orchestrated SageMaker and RoboMaker. Hence, you can see this hierarchical architecture which takes the burden off the customer and operates the feedback cycle of reinforcement learning under the hood. However, in this setting, if you want to look at and debug your code and also watch how your robot is doing in a simulation environment, we provide the model checkpoints in an S3 bucket, and we provide CloudWatch logs where you can go and debug your code. And finally, By going and logging into the AWS RoboMaker simulation service, you can open a window where you can watch your robot both through training and evaluation processes. And you can record videos and you can look at them later after the training as well. Now, as we talked about having to decouple the simulation environment naturally comes to Ray RL, but it also helps us solve one of the challenges that we had mentioned, which was making sure that our simulation agent transfer well into the real world. So by decoupling and using Ray and RLlib to scale both your simulations and trainers, you can actually give different simulation environments with different lighting options, with different tracks, with different layouts where your robots are operating. You can make your agents more robust to changing conditions. In the case of AWS Deep Racer, lighting and changing colors of the tracks and varying tracks has been one of the challenges that we had to deal with, and we extensively have been using different simulation jobs in order to create robust agents for simulation to reality transfer. Let's consider a third-party use case. Last year, we sponsored a NeurIPS competition in collaboration with AI Crowd, and there we were able to benchmark Ray RLlib towards a very popular yet difficult gaming environment called ProGen, developed by OpenAI. I highlighted here two of the columns to give you an idea about using AWS using Amazon SageMaker and AnyScale's Ray RLlib. You can use a single instance which has multiple GPUs, which is on the far, and you can use the one column before that where you actually use multiple instances with a single GPU. And the performance in terms of reaching 8 million steps, which was our constraint for this competition, that you can see that is between 30 minutes and 23 minutes. There's a little bit of communication overhead when you use multiple instances of GPU. And however, if you compare the two, they are relatively close to each other. It's 30 minutes versus 23 minutes. And in terms of cost, they come out to be the same. If you want to know more about this use case and you want to test it with your environment using Ray RLlib on Amazon SageMaker, we provide the code. It is available to download from GitHub. Let's take a step back and look at some of the customer use cases. As I mentioned before, I'm going to today focus on two customer use cases. One of them is the use case by GE Aviation. In this use case, there's a robotic manipulator, which is a fennec arm, and it has been trained with the reinforcement learning agents in order to enable manufacturing. And we're going to watch a short video of how the reinforcement learning agent is trained. Initially, our customers at GE and our collaborators had been using simple laptops in order to test and quickly iterate. But through Amazon SageMaker, Ray RLlib, and Kubernetes and Kubeflow Pipelines, they were able to now expedite this process and scale to multiple robots. Our customers in Woodside Energy, they had been using a navigator robot, which we're going to see in a moment, with dual arms in order to do plant operations. And what they had been seeing is that it is very difficult for the robot to create some of these behaviors, and they're looking into using reinforcement learning. Hence, they onboarded with our SageMaker RoboMaker platform, and they had been an early adopter of the Kubeflow pipelines that we had provided during this presentation. Let's take a moment and look at the GE use case. In this case, you are seeing first in a simulation environment. And as I mentioned, the simulation environment doesn't have to be AWS RoboMaker. I provided my examples for that use case as it is the more complex scenario. You can also use PyBullet, Mujoko, or other popular simulation environments on our platform. So in this use case, you're seeing several examples of how the reinforcement learning is using multiple simulation environments in order to train a robotic manipulator. And then finally, towards the end of the video, we're going to see this agent deployed into a real robot. And as you can also imagine from some of these examples that you don't want some of these behaviors to be applied in real world on your robot. It is you would be as you're constrained with the space and different kinds of behaviors you would like to do. So on the top you're seeing the simulation, and in the bottom, you're seeing the real robot starting to enable the behavior that was learned by the reinforcement learning agent. In this use case, robotic manipulator is performing what we call a homing operation in order to bring the configuration of the robot into a specific location in space. And as you can see in this case that the deep reinforcement learning agent was able to avoid most of the collisions that may otherwise happen when we are using the benchmark algorithm that we compared the DRL agent to. Our next use case is from Woodside. Let's take a look at the Woodside use case. The Woodside has a robot that was built specifically for their use case, and the name of this robot is Ripley. It has been a collaboration between Woodside and several universities, and I provided a link for you to watch the different components of this robot. What we've been able to do is to work with Kyle's team at Woodside Energy and bring the gazebo agents, the gazebo components and assets to the AWS RoboMaker, which you're seeing on the left. And you can see the robot is about to perform an operation that is related to a power plant. And it will be actually trying to open and close some of the valves that are in place. And on the right, you are seeing the actual robot, and you can see that the robot in simulation and actual are one-to-one match, which is another important step for us to enable sim-to-real transfer from simulation to a real-world agent. Kyle's team is in the beginning of their journey. They started with the Kubeflow Pipelines, and we were able to start training reinforcement learning agents in the simulation environment. In the next couple of months, we'll be working very closely with them to test simulation to reality with the agents that we trained with the platform that I had provided and presented in this talk. Finally, if you would like to get started with reinforcement learning workflows using Kubeflow Pipelines and Amazon SageMaker, you can get started by first reading our blog, where we provide step-by-step instructions on how you can set up your computational environment to use the Kubeflow Pipelines, Amazon SageMaker with Ray, RL Lab, and the simulation environment that is available to you through AWS RoboMaker and or a different simulation environment that you can bring in. And finally, the code for the Kubeflow pipelines for this very same talk is available on GitHub, and you're welcome to try it out. I would like to thank all the participants and I would like to thank the organizers for giving me the opportunity to talk a little bit about what we are doing at AWS and Amazon, enabling our customers to seamlessly integrate their workflows for reinforcement learning. Thank you.